Well, before we even worry about what the heck those i's mean, let's just do it with x. So say this were 4x times 3x. 4 times 3 is 12. And be careful with this. A lot of people just say x, but remember, x times x, I have to add my exponents of 1, so I actually have 2, so x squared. Well, in the same way we just multiplied 4x and 3x, we're going to multiply 4i and 3i. Even though I is negative, or even though I is the square root of negative 1, we can still multiply I times I to get I squared. And now that we know that I squared is negative 1, we can also make that substitution. So 12 negative 1. Well, I can keep going. I still got more to simplify. 12 times a negative 1 is a negative 12. So notice when I multiply two imaginary numbers, my two imaginary numbers actually become a real number in the end. Why? Well, again, my square root of negative 1, which was I, when I square it, just becomes negative 1. So it's no longer imaginary. It goes back to a real number. Well, why are we doing this? Well, this is important when we multiply complex numbers together, which is what we're going to do here in a second. The strategy to multiply complex numbers is the same strategy that we used on the warm-up slide when we multiply those binomials with the x's in it. Well, the same thing is going to happen here on slide 5. So I want you to go ahead and pause the video and try this out for yourself, and when you're done, you can scroll down because there's more at the bottom. Alright, so whether you use FOIL method or box method, up to you. Either way, you're going to end up with 18, 12i, 9i, and 6i squared. Which, if we look below, we see is in fact correct. Alright, well now what? Well, I just multiplied two complex numbers, and I want to write my final answer as a complex number, so I got to do some simplifying. So I take my 18 plus 9i plus 12i plus 6i squared, and we're going to simplify it. And we're simplifying it in the same way we simplified in the warm-up. I can't combine terms if their exponents don't agree. So I can't combine 18 with anything because there's no other I with an exponent of 0, or there's no other term with no I. I can't combine 6i squared with anything because there is no other I squared. I can only combine my 9i and my 12i. When I combine them, I end up with 21i. Almost done. The last thing it tells me to do is to rewrite I squared as negative 1. So rewrite I squared as negative. All right. So we're close. Still not there yet. Let's take a look at the next box below. Combine the real components to get your final answer in standard form a plus bi. So standard form just meaning real number plus imaginary number like we talked about last class. Well, let's keep simplifying. 6 times a negative 1 is a negative 6. Notice I now have like terms again. I have an 18 and a negative 6. 18 minus 6 plus 21i. Almost there. 18 minus 6 is 12. 21i. I now have it in complex form. 12 plus 21i. Real number is 12. Imaginary number is that 21i. So that's what we're going to do. Multiply two complex numbers. Write the final answer as a complex number. All right, go ahead to the next slide where I want you to pause the video and try these two on your own. All right, let's see how you did. So this first one, when you multiply out, you're going to get 8 plus 2i minus 20i minus 5i squared. 2020, there we go. So same process. Combine like terms, substitute for I squared, combine like terms. So we're sandwiching that I squared in between combining like terms. So the first two like terms, I'm going to combine into 2 and negative 20 to be a negative 18. Next up, I have minus 5i squared. Well, we know that I squared is just a negative 1. Now I can keep going. Negative 5 times a negative 1 is a positive 5. Notice what really ends up happening with that I squared is it's essentially just changing the sign of my value. What do I mean by that? Let's backtrack a second. Negative 5i squared. Well, negative 5i squared, as we just did, negative 5 times negative 1 became a positive. So I went from a negative 5i squared to a positive 5. So that I squared, since it's a negative 1, is simply just changing the sign in front of my value. All right, let's keep going. So I have 8 and I have 5. Those are like terms. 8 plus 5 is 13. I am now in complex form, in that standard complex form where my real number comes first and my imaginary number comes second. That's it. All right, number 2. Number 2 is going to be a little bit different, but everything about it is going to be the same. Our final answer is going to look a little bit different, and we'll see what I mean in just a second. 1 minus 6i plus 6i minus 36i squared. So when we go to combine like terms, we should have noticed that I have a negative 6i and a positive 6i, which just amount to nothing. So unlike before where I was still left with an imaginary number, we see in this problem that they actually end up canceling out, and I'm left with no imaginary number. That's okay, that's going to happen sometimes. So I just have no imaginary number for this problem, but I'm not done yet because I still have an I squared that I need to account for. So negative 36i squared, replace I squared with a negative 1, becomes a positive 36. Well, we got a nice little algebra problem here. 1 plus 36 is 37, and that's your final answer. And that is your final answer in standard complex form. So just because the imaginary number is not there doesn't mean it's not in complex form, because what your imaginary number is 0i. We don't include stuff like 0i or 0x in our equations. So 37 is your final answer. All right, next slide, slide 7. Slide 7 is just a review from last week. We're taking what we learned about factored form, and now instead of just doing real numbers in our factored form, now we're going to also be doing imaginary numbers, but everything else stays the same. So go ahead and pause this video, find the zeros, put it in factored form, and then check in with me. All right, let's see how you did. So we have x squared plus 9. It's asking me to find the zeros. Well, as we know, find the zeros just means set your function equal to 0. All right, so now I have it equal to 0, but how am I going to find? How am I going to solve? Well, what we should notice is we have x squared and 9. I have no b term, so I have no x term, which is going to make my life easier because I can just solve this by square rooting both sides. But before I square root both sides, I got to get x squared by itself by subtracting 9 from both sides. Let x squared was negative 9. And now I can square root both sides. And the other key thing to remember is when you square root both sides, you have to do plus or minus. Do not forget the plus or minus because this is a quadratic with x squared, meaning 2 x's and 2 solutions. And as we know, if we don't include that plus or minus, we're just going to end up with a positive 3i and miss the negative 3i solution. Okay. Not quite done yet. Because like I said, we need to finish simplifying. And to finish simplifying, we just got to take the square root of -9, which, as we learned last class, is just 3i. So we know for factored form, we need 2 zeros. Well, my 2 zeros here are 3i and -3i. Now it's just a matter of plugging them into factored form. And like I mentioned, it is the same. Sorry, I got lost in the slides. There we go. It's the same process as before. Okay, so sorry about that. Here we go. So 3 and -3i are my zeros. I'm plugging them into my factored form. 3i, -3i, and as we talked about before, minus a negative always becomes a positive. So the last thing we need to cover is that leading coefficient. Remember, the leading coefficient just comes from that value, that number out in front of the x squared. Well, as we can see, I have x squared with no number out in front, which means it's just a 1. And like we've discussed in the past, 1 times anything is itself, so it doesn't change anything, so we don't need it. So that's our factored form. Notice nothing different than how we've been doing it, other than now we can put imaginary numbers in factored form. But the process is the same. So let's go ahead and check our work. And what do I mean by check our work? We just came up with the factored form of x minus 3i and x plus 3i. So we're going to use that box method to check our work. So go ahead and pause the video and check for yourself. All right, let's see how you did. So remember, box method, you're going to assign each piece of the binomial a box. And we just multiply. X times x is x squared. Now this is the piece that trips people up, and that's the 3i times x. Well, remember, 3i is just a number. So in the same way I multiply, say, 5 times x to get 5x, I multiply 3i times x in the same way. So my answer is just 3i x. I know it's weird with those 2 letters back to back, but just remember that 3i is a number. Same thing for the other one, -3i x. And this last box is -3i times 3i. Don't forget to multiply the 3's and the i, so we end up with -9i squared. So put that together. But notice 3ix and a -3ix, they cancel each other out. So then I get left with -9i squared. And like we talked about before, -9i squared, that I squared is just going to simply change the sign, so it is a x squared plus 9. So yeah, we just verified that yes, indeed, x minus 3i times x plus 3i is in fact the quadratic, or the factored form for the quadratic.